back. I'm here with Vit, the CTO of Goliath, and we're going to be talking about device security. How you doing, Vit?
I'm doing great, Chris. How are you?
Yeah, great. I've heard in the past, anecdotally, that the S in IoT stands for security. Is that correct?
Oh, you're spot on. I think yeah, historically, I think a lot of people when they started building their devices, they were just happy to, have things connected and
That's right. Yeah. Yeah. Get past the
security.
talking part, and it's there, and it's like, all right, I'm sending something back. Who knows about this thing out there, anyways?
Yeah, yeah. So I have my telemetry. Who else is interested in my telemetry anyway?
Yeah.
Like who wants to know about whatever my temperature in
Yeah.
my garden or whatever?
Right.
Yeah. So I hope, or I see that these days, we are kind of past that, and people would rather have the security inbuilt and not having to think about it, than build something and then having to bake security in later on. Because yeah,
Yeah.
that seems to be a more difficult path.
That's right. And people cannot actually connect to the Goliath cloud unless they are on a secure connection. So, like you said, it's built right in. You don't really have a choice.
Yeah, we make it a little bit more difficult for them than plain text communication, but they'll get all the benefits and all the advantages and peace of mind uh, by using security by default.
Hmm. And so you've been writing about PSK. What does PSK stand for?
Oh yeah, I've been writing about pre-shared keys, PSK. They are basically an equivalent of you using a password or you giving someone some secret thing, but between humans, it typically is a password. So let's say you want to, I don't know, enter a building or let somebody know that you are authorized to, go to your friend's place, and you say, oh, if I'm coming, I'll knock 3 times fast, 2 times slow, or I'll say abracadabra before I enter. So that way you establish between you and your friend the fact that, this is the secret that only the two of us know. And if somebody else will try to enter, they will not know the way how to knock properly or what to say. So they might guess things if, the knock is too easy. If you just say knock twice, chances are by coincidence you'll make it. But yeah. So I think that's a good analogy of
Okay.
shared secret.
Yeah, that's great. And so then that contrasts with like a certificate-based system, kind of like the opposite, not the opposite of that. Another option is to have certificates so that things that hold that certificate, it's like stored on board, that's kind of holds those keys, holds the information that it requires for crypto authorization, right?
Yeah. So I always see the security as a scale between convenience and complexity, or convenience and the degree of security. And you typically cannot have both. Like you cannot have a super secure but also convenient to use system that just doesn't work at the same time. So there are some trade-offs that you need to make. And going with certificates, that's awesome because it's super secure, and you have a lot of flexibility in the way how you want to delegate various parts of establishing the trust and establishing the authentication process. But it's damn complex. It's like really, really complex. So if I go back to the improvised analogy of you want to visit a friend, so let's say with your friend, you would agree that there would be some paperwork that you first both, I don't know, you go to a bank or you go to a notary, you sign that paperwork in front of a notary, and then when you want to enter the place you wanted to enter, you need to bring this paperwork with you, and you need
Yeah.
to, I don't know, present that paperwork to the other party, and the other party needs to go back to the notary and check, okay, have you actually, like, is this actually your signature on that? And yeah, so
Yeah.
it's
Yeah.
overly complex for some initial proof of concepts, or simple things where you really just want to get your telemetry off the ground and of the device, you don't want to spend hours dealing with certificate,
Right,
right?
right. Well, especially because Goliath's a new platform. Most people coming in are going to be like doing proofs of concept. They're going to be trying things out, and we're really good at that. I mean, right? That's like something where you can stand up a demo. I got a demo I was doing for someone. It was like 2 hours to get like all the way to have like a cellular product, basically, from the idea to like a cellular connected product that I could update firmware and like change stuff on it. Like 2 hours? That's insane. And it was totally secure too. So yeah, I don't think
Yeah,
that
yeah.
that's crazy.
I think in that case, my thoughts were really like, can we give someone something they can just copy paste, or something that's easy to review? Is the part that I gave my device, the PSK, that key, is it the same as the one that I have on the cloud? It is? Okay, then it should work. Whereas, yeah, if you go the more complicated way, it's like way, way more difficult to check that. At which point things are even failing, because there's the server authentication, the client authentication, and all of that shebang. So with the PSK, things really just boil down to: do you have the same PSK? Yes, I do. No, I
Yeah.
don't.
Yeah.
And either you are allowed in or not. And then there is, of course, all the overhead of your crypto libraries and you doing TLS or DTLS properly with our platform. But thanks to our SDK, that should be solved for you by default, and you can just focus on basically your telemetry and you sending data, and all the abstraction of the security is done by us. So it should be really as simple as copy paste.
Yeah. I mean, people that have watched videos on this YouTube channel, or if people haven't watched videos, there's many examples of showing where basically it's just in the project.conf file in Zephyr. It's basically like your Goliath, your PSK ID and your PSK. So basically username, password, and you get that and you show up as that device. Let's quickly show what it looks like to add a new device or add a new one here. So we can actually create a new device and provision it with credentials. Create this basically gives us a default funny sounding but unique name here. And then if we want to, they can borrow for the ID and then, make this a super secret password, of course. And, that could be whatever you want. You could have it stored in a keeper or equivalent, password keeper. And then you have PSKs. And then even if you wanted to, you can have multiple keys, right? So you can have multiple PSKs for a particular device. So I could go and add a second ID, and then a second password, and this is something that you also wrote about, Vit, in terms of another way to layer security onto here.
Right. So maybe for proof of concept, this might be too complex, but a lot of times people start thinking about, okay, so what if the password gets compromised, or what if I don't want to have a device out there in the field using the same password for years and years to come. So there is the concept of password rotation, or rotation of your credentials, and that way, let's say, you can basically give your device not one identity but two identities at the same time, and the device can decide to use one or the other, and then in the rotation process, you basically end up replacing the identity you are not using with an updated one, and then you can swap between them. And the beauty of that is that people in the past, if they had just one password, they would end up in a situation where they would update their PSK and suddenly they cannot connect because something in the process went south and the device just wouldn't connect for whatever reason. There are so many things in the chain of updating things that can fail, and basically you bricked your device remotely that way. So having two passwords saves you from that, because you basically update the one that you are not using anyway, and if something happens, you just revert to the previous password that you were already using, or the PSK you were already using, and try again later.
Yeah, That's great. That's great. Yeah, that's good. It's good to have those backup methods as well. So yeah, I think this has been a good, quick overview of PSK, what it is, how we can quickly implement it using Goliath, and I think, like you said, it's pretty much good enough for a proof of concept. We'll be talking more about other security topics in the future, like certificates, like other methods of authentication. Anything else people should know about security as is right now on Goliath?
I think that's pretty much it. Yeah. Basically, authentication with PSK. Authentication is a different thing than the actual encryption and the security during communication of your data. So, yeah, I think you can in the future focus on the other methods of authentication we want to do, which is certificates and throw keys. And then we can also maybe cover the stream encryption and how the data is actually protected on the fly.
Yeah, and I think, like you said earlier too, like a lot of this, if you're using our SDK, if you're using the cloud, a lot of this stuff is already taken care of for you, and so you don't have to think about it, and it's easy to get bootstrapped up quickly. That's what we're really focused on right now, and we'll be covering other things in the future. So thanks so much, Vit, for telling us about it, and we'll see you in the next video.
Thanks, Chris.